Open shortest path first is a link state routing protocol. On another protocol, which is also link state, is ISIS. Now, both the protocols are really good. Most uh, reliable, the best is ISIS, but not many people know ISIS, so the organization also don't want to hire a costly engineer who knows ISIS, so they're okay with OSPF, you know. But the reality is, when you replace ISIS with OSPF, ISIS with OSPF, remove OSPF, put ISIS, your network is going to be super excellent. Not simply excellent like OSPF. OSPF is an excellent one compared to other protocols, but ISIS is super excellent. Very, very nice one. Better one, more efficient than ISIS. For various reasons. We'll talk about those things when we are in ISIS. Now, this open shortest path first follows an algorithm to find the shortest path. It uses an algorithm called Dijkstra's algorithm or SPF algorithm. And this routing protocol is using this algorithm. That is why it is OSPF. And this routing protocol is open standard. That is why the O. So OSPF is not SPF algorithm. OSPF is a routing protocol that uses an algorithm called SPF. OSPF is a separate protocol. SPF is an algorithm used by the protocol. SPF is also kind of open standard idea, yes, and it is widely seen in various places, even Microsoft processors, operating systems, the threading, they use SPF shortest path to locate the data in the hard disk, to locate the data in the memory and CPU. The same SPF is what even Intel uses, but the operating system, sorry, the routing protocol OSPF is different. Routing protocol's purpose is to find the shortest path by calculating the cost. Now this SPF algorithm, sorry, OSPF routing protocol has got a number to identify. That's what we need to know. Every protocol has got some number to identify. You and I speak English word OSPF, but for the device, the operating systems that runs this protocol needs to know who is talking. If OSPF is talking, it needs to say 89. I am 89 speaking. I am IP protocol number 89 speaking. So that's another thing that you can expect in interview. IP 89 is OSPF, IP protocol number 89. And OSPF, to discover neighbor, it uses hello packets. So the question may be the timers. How often the hello packets are sent? Can we change the timer? These are all the questions they ask. Answer is 5 and 15 is for EIGRP. Don't say 5 and 15. This is 10 and 30. 10 and 30. Is it 30 or 40? Hello timer is 10 seconds and that time is 40. All right. See, it's confusing because we don't think this one often. That is why. But for the interview, this is important. We should know this number. Otherwise, they think that we don't know. But you know it. You know a lot of big things. But when we don't say that 40 number, they think we did not because it's only 15 minutes time you have to prove yourself. No? So better, at least for interview sake, we have to remember these numbers, 10 and 40. Now, this 10 and 40 can be changed, but if you change it on one side, you must change it on the other side, this port and this. You have to change it on both the side, both the ports. Otherwise, the neighbor won't come up. One of the important parameters that should match in order to form neighbor is hello timers. More precisely, the dead intervals. Always 4 time of hello is dead. So if you change the hello timer, dead time also changes. So it will look for dead timer. Dead timer should be same on both the end. So I can have different timer here, like 10 and 40, and I can have here maybe 20 and 80. It's your wish, you can do that. But mostly people won't do it. They will leave it default. 10 and 40 is the timer. Hello timers. But this hello timer is not same for WAN. What is WAN here means? WAN doesn't here mean WAN connection. It means the type of connection in WAN, like NBMA. If it is an NBMA, then it is going to be 30 and 120 that time. Now, when we talk about NBMA, the non-broadcast mode and point to multi-point mode and point to multi-point non-broadcast. So there are 3 types: non-broadcast, point to multi-point, and point to multi-point non-broadcast. These 3 more types timers are 30 and 120. Non-broadcast. This is one of the NBMA mode, and then point to multi-point. And then these 2 are industry standard, RFC standard. And there are other 3 Cisco standards in which the first one is point to multi-point non-broadcast. Now these 3 timers are 30 and 120. Okay, so NBMA modes, that is another topic. They may ask question, what are the NBMA modes that Cisco supports? Cisco supports 5 different type of modes. 3 I have written here. 2 more is broadcast and point to point. Yeah. So totally 5 modes we have, NBMA modes. That's one question they may ask. And then timer, that was another question we started. Timer is 10 and 40 for normal broadcast, not NBMA broadcast, normal broadcast and normal point to point. So I can say LAN. In LAN, it's only 10 and 40. In WAN, NBMA, there is another. In WAN, NBMA also you have broadcast and point to point. There also it is same 10 and 40. But this is in NBMA, non-broadcast multi-access, in that broadcast type, in that point to point. Whereas this one is simply normally simple broadcast, like you have a layer to switch. Whereas here it is not layer to switch. Here I said frame relay switch. So they may not go this deep in interview, but you need to have clarity. If they confuse, also you should not get confused. In a LAN, it is 10 and 40. In WAN, in NBMA, 30 and 120. 30 and 120. What are the 5 different modes of NBMA non-broadcast? Point to multi-point. Point to multi-point, non-broadcast. Broadcast, point to point. What are the differences between these 5? We'll see later. Even this NBMA 5 modes, I was not willing to speak now because we need to go in proper sequence. Our main focus was to know the difference in timers. In a LAN environment, it is 10 and 40. In WAN environment, it is 30 and 120. Only this much you need to know now. The other things, if you have questions, don't worry. We'll go there. We can discuss on those NVMe types later. Now, let us quickly get into the presentation so that we will go in a sequence. I'm not going to teach, we are preparing for interview. I still remember this picture is a very nice picture. How OSPF picks the best path. You see, it's a link state routing protocol we saw. LSAs are distributed to every routers. By collecting link state advertisement, what do you have in link state advertisement? That may be another interview question. People like me will ask such questions. It may not be there in the ready-made questions in the internet, but I like to ask this type of question. What do you have in LSAs? What does LSA, link state advertisement, carry? If you don't know much, also the word itself, if you just pronounce it slowly, then they will think it as an answer. Link state advertisement. It advertises the link status, meaning the bandwidth on the link. Based on the bandwidth, the cost is determined. So the bandwidth on the link, the network, the mask, and the timer, and the router ID. This is all shared. Now, this is a output of router LSA. A screenshot of router LSA. So what you can see here is the router ID. See who is advertising this. The advertising router's router ID is 4.4.4.4. And then what it is carrying, it is carrying the networks, the metric, the subnet mask, the metric based on the cost, and then it is this is just simply talking about whether this router can, the sender, the 4.4.4.4 is capable of carrying LSA type 5. But this is not the main story. Okay, advertisement age 6 seconds ago. Length of the packet. So this is the main information. This one, who is sending this? ABR is sending, and what is the router ID? Right, and what type of LSA it is? Type 1 LSA, which is called as router LSA. Okay, now this LSA is so LSAs are sent whenever there is a change. Hello packets are sent every 10 seconds. That is different. This is different. You see here, after forming neighbor, these LSAs are exchanged. So don't think that because this chapter starts, this is the first chapter and the very first slide, don't think that hello packets are sent, LSAs are sent, both are same. No. LSAs are later. First the hello packets, and when the parameters in the hello packet matches, yeah, Jana, correct. Exactly. That's the right understanding. That's right. So first the init state, two-way state, xstart state, and then only this sharing of update exchange state comes, LSS comes. That's a very good understanding. The DR is what the election process in xstart state. If it is broadcast, if it is point to point, no DR there will be master slave, and then the exchange starts. LSS exchange between the routers. So the LSAs are not the first packet. That is what I want to say. If the hello packets, if the init packets, if the hello packets don't match with the parameters that's supposed to match, this won't come. The exchange of LSA will not come into picture itself. It won't even go to two-way state. If the hello packets are not having the right uh, informations that's supposed to be, it won't go to the state. So we'll talk about the adjacency states. You already know it, but we'll come to that later. Let's go in the sequence. I don't want to miss any topic. That's why I've started this presentation. Um, Otherwise, we'll be jumping from first chapter to the fifth chapter, and then again coming back to the second. Not good. So let's go in sequence. The advertisements sent by every router forms a big database on the routers. And one point I want to very clearly say here is within an area, this database is going to be identical within an area. We know we have areas. Within an area, there will be identical database. You see, the database will be similar if you take any router inside an area. Try typing show IP OSPF database, show IP OSPF database. You will see identical database on every router within an area. Within an area, the reason why we are saying that, some advertisements, they don't cross the border. So you cannot expect similar table from different area. Type 3, for example, is sent from one area to another via AVR. Type 1 and type 2, they don't. So the receiving routers in the other area will not be able to show you the type 1 and type 2 of other area. That is why we say within an area, you will have identical database. Not only that, we also do summarization on ABR that also will make the database look different on other areas. Now this linked database is referred by the protocol SPF to find the best path to reach remote networks, far away networks. And then the route is elected and installed into the routing table. But I cannot say that. I cannot guarantee that. See this, I'm trying to just interpret this picture. But see, SPF algorithm finds the best path, and the OSPF is recommending the path to the routing table. That's what we can say. Why? Routing table will also again check the administrative distance, no? So final decision is made by the routing table manager, not by OSPF. OSPF is not deciding whether the route will go to routing table or not. Is it OSPF deciding? No. OSPF will recommend. So this is what the shortest path. Let's say for the same destination, EIGRP also recommends. Routing table will take only EIGRP's advice, not the OSPF. Why? Why, Jana? Why it takes EIGRP's recommended route, not the OSPF route? Why? EAD value. Sorry for bothering you in this time, but I just I'm curious to know. So it is the AD value. So the decision is made based on the prefix length, AD, etc. in the routing table. Fine. So we will not focus on the routing table manager side. We will focus only on OSPF and discuss. So OSPF installs the route into the routing table to keep it simple. Okay. And we have topology table, which is called as links to database. We have neighbor table, the list of neighbors, router ID, with whom the adjacency is successful. Will be seen in the neighbor table. As we already discussed, routing table will be having the best route to various destinations. Why link state routing protocol? Because link state routing protocols are more accurate, because every router only sends the link state advertisement, not the routing table. I want to repeat again. Why link state routing protocol? To answer that, why do we need map? When you have map, you can make accurate path selection. When you don't have map, what is the other way of knowing the path? The other way is go to every street corner, ask how to go to Mudumalai. Okay, they say go straight and then 15 kilometers. You go ask there. Then you go there 15 kilometers and then you ask again how to go to Mudumalai. Again, they direct you to a certain distance. Keep asking every, but is that accurate path? Who knows? It depends on the knowledge of a person who has given you the info. If the person is like me, then you will end up in landing in a long distance route, because I don't know much about areas in Karnataka, in Bangalore. So I am here for more than a decade. I don't know. So if you ask me just to help you, I'll say, yeah, go straight. You will find. Because I have gone there in a jeep. But you are going by walk. That may not be the best route for you. Walking roads are short roads. I don't know those roads. I know only one road, the main road. I'll tell only that. See, that is how the other protocols behave. The other protocols advertise their knowledge, advertise their routing table. That may not be accurate for the receiving router. So instead, if you have a map, instead of asking the neighbors, if you have a map, you yourself can position your location in the map and the destination in the map, and you can decide what all paths, and the best path is this. You can decide on one best path. You can see what all paths available, and you can pick one best path. So link state routing protocols only can give you accurate information about the topology. That's the main reason why we want OSPF. Not only that, when the best path goes down, immediately you can pick the alternate path from the database. What if there is no alternate path in the database? If there is no alternate path in the database, it means that the alternate path doesn't exist. Whereas in the EIGRP, when there is no feasible successor, the queries are sent because there are chances that alternate paths may be there. Whereas in OSPF, not at all possible. If there is no alternate path in the database, it is 100% guarantees sure that there is no alternate path. They don't exist. They don't exist. Right, and then there are two types of hierarchy. The reason why we need this hierarchy is, see, three valuable points. Why do we need areas? Why do we need this hierarchy? Let me answer the first question. Why do we need hierarchy? So that this guy will be the middle, the backbone will be a transit. Instead of all area talking to all other area, if we just talk to one common area, that's why we need a hierarchy. Secondly, what is the advantage? Because you are all talking to one common area, if you summarize the route and send to that common area, that summary route will be distributed to other areas. As a result, you can minimize the routing table entries because you are sending summarized route and they are receiving summarized route. So all the receivers will have optimized routing table, minimized routing table. Not only that, if any subnet goes down in this local area, it won't impact the entire topology. It is within the area. Because you are doing summarization, the detailed LSAs are stopped in the borders. Right? For all this good reason, we need to have hierarchical design. And these routers C, D, and E are ABR routers, we know. And this is internal to area 1. These A and B are also internal to area 0, but they are also called as backbone area because they are in the backbone. One big difference between ISIS and OSPF is, in OSPF you have a dedicated number called area 0 to be called as a backbone area reference number. Can you use any other number in OSPF for area 0, sorry, as a backbone area? Not possible. Not possible. Only one number that is dedicated for area 0. And area 0 alone can be a backbone area. In ISS, area number is not going to determine the backbone. It is the L2 adjacency that determines the backbone. We'll not go to the ISIS side. Just I want to tell you this one difference, that ISIS and OSPF, even though they are link state routing protocols, there are some big differences, like area especially. You see here only two-tier architecture. All the area must be connected to a backbone area. You will not see this type of approach in ISAs. I can have area, another area, another area, another area, another area. I can have like this. In OSPF, it is not possible. In OSPF, all area must be connected to backbone area, area 0. In ISAs, this is possible to have. And ISAs, even though it supports this type of design, it is still scalable. It's really scalable than OSPF. But only those who know very well ISIS can make it more scalable than OSPF. If you know only simply to enable ISIS, then that's not enough to make it more scalable. All right, let's not get into that again. Just one difference I want to show you here that I have shown already. You see there is no area 0 here. There is no which area you will call it as backbone. All area are connected to other area in a serial consecutive manner. So you cannot call any area as a backbone area in ISAs. Whereas in OSPF, you must connect all areas to a backbone area. Okay, the point that I was trying to recall, I forgot and I was struggling is this. You need a virtual link in OSPF in case if you are connecting another area below here. Area 4. So area 4 needs connection to backbone area. So either you give a physical wire or a virtual link. In ISAS, that is not needed. Let us move on. This is a well-known story, ABR. I don't want to get into these things. Hello packets are sent every 10 seconds, as we already discussed. There are certain parameters that must match in the hello packets. For example, the timer should match. And the subnet mask should match. And then area ID should match. And then if you have authentication, then that also should match. Authentication type and authentication key, both should match. And then if you have stub configured, then stub type also should match. You know, if any one of this is not matching, the neighborship won't come. What about the priority? Do they need to match? No. See, priority will be sent in the hello packet. Did anyone say anything? Area ID. Area ID is mandatory, must match. Area ID should match. Authentication type, authentication key or authentication string, sub. These are all mandatory, should match. If any one of this is not matching, the neighborship won't come. All right, there are many other things than in the hello packets we see. One is router ID, which should not match. Router ID should never match. If it is matching problem, router ID should not match. Co is saying, I am co giving you. If I also use the same word, I am co giving you, then which co gave you what? Confusion. And whatever I give, co will not accept whatever co give because I am also co, he is also co. We won't receive our own updates because it has got my own name. I won't accept my the update sent by co, and co won't accept the update sent by me because I'm putting the name co. Co says, why should I accept my own update? It will cause unnecessary loop if I buy. So route ID must not match. Router ID need to be unique. Okay, next. What all need to be unique? The neighbor list need not to match. Neighbor list will also be sent in the hello packet. The neighbor list need not to match. Let me quickly take a screenshot of hello packet and show you. Yeah, so serial wires are not connected through a switch, so you cannot have more than two routers. Only two routers connected back to back, and there is only two routers. There is no need for DR-BDR election. See, if you are only 2% going to alter your network, there is a maintenance weekend. You want to do some big alteration to your network, some migration, and only two people are there to do it. Then why you need a leader? No need. You will tell that what all you can do, and you will give the rest of the job to your friend. That's all. But when there are many people, then there is a need for a team lead who will allocate jobs to the team members so that no one will do the same thing what other is doing. Everyone will do the unique one and migrate it faster. If there is no team leader, then I may like to enable OSPF. Then my friend who is in the the other shift, he also likes to migrate to OSPF. Then we will do the same job, which is called loop in the networking. To avoid loop, there is a DR-BDR election. The router with the bigger priority becomes a designated router. The default priority is 1. The default priority in the LAN environment is 1. In point-to-point, the priority is 0 and priority has got no significance. In point-to-point, priority has got no significance. So even if you set some priority, the DR-BDR will not come in point-to-point. In a LAN environment, the default priority is 1. So you can go to one of the router which you want it to be a DR, go to the interface and say IPOSPF priority and give some high number before the election starts. Before you unshut the interface, you should say the priority. After election, if you give high priority, it's of no use. Then you have to restart the OSPF process on all router. So before OSPF sends the hello packets, you need to change the priority. If you don't change the priority, then there will be a tie in the priority. The router with a bigger router ID becomes the DR. Now you see, a router can be a DR, can also be a BDR or DR other. For example, F0/0, for this segment, this is a DR, because the priority is 10 here. For this segment, I did not set priority. Here also priority 1, here also priority 1. And the router ID here is 11.11.11.11. The router ID here is 1.1.1.1. So what will happen? Here it will be BDR. And here it will be DR. So what I'm trying to say here is one router can be a DR on one LAN. This is one LAN. And BDR on the other LAN. And DR other on the other LAN. Other LAN. It depends on each segment. Right. So this one we already discussed, link state database. On top of link state database, the SPF algorithm will run like this. and find the cheapest cost path for each destination. That is how the best routes are determined. And this is a very nice page that gives a clarity of how the synchronization of database happens, how the link state database synchronization happens. See, there are many routers now in an area, but we told that all the router in an area will have identical database. All the routers in that area will have identical database. How is that possible? If they do proper conversation, only then it is possible. Now let's see how they do that synchronization without any confusion. Whenever there is a change in the link state advertisement will be sent. But while sending, it will always increment the sequence number. Yes. Every update will have a sequence number. That sequence number will be incremented by 1. Whenever there is a change, whenever LSIs are sent, sequence number is updated. So this advertisement, link state advertisement or link state update, is coming into the router. The router receives an update. Now, the router which is running OSPF receives the packet and checks whether the OSPF database is empty or having some info. If the database is empty, see there is nothing in the database. Then whatever comes in, it will simply add. It adds to the database. And then after adding, it sends the acknowledgement to the sender. Afterwards, it floods the information to the rest of the downstream neighbor and runs the SPF algorithm on the local database. Best path is elected and given to the routing table. The end. So this is only if the database is empty, only if the router receives the update for the first time. Now, if the database has got already some entries, then it will check the sequence number on the entry. Is the sequence number which I already know and which is coming now or the same? If it is same, I have to ignore because I already know. If it is not same, I need to check whether the sequence number is higher. If the incoming sequence number is higher, then I need to update my database. And then send this acknowledgement, send the LSC to other neighbors, run SPF, end. In case if the received packet sequence number, let's say this is 7, but what I already have in the database is 8. In that case, the sender is not up to date. So I have to send the advertisement to my sender saying, I got the latest one. And then the end. So this is how the routing, the OSPF distribution of route information, the distribution of database gets synchronized without any confusion, because they use sequence number. Sequence number helps them to have a unique database. If there is no information in the database, whatever comes in, it adds to the database. If there is information, it checks whether the information that I know and incoming is same. If it is same, then I need to ignore, because the sequence number is same, the information also will be same. See, if it is not same, then is it higher? if it is higher, then I am outdated, I need to update. If the incoming is lower, then I am already updated, the sender is not. See, using this sequence number thing, you may have a question in the interview. Right. Now let's the hello packets which are sent to a multicast address 224.0.0.5. Within a LAN, if you have many routers, first packet will be sent as multicast, and followed by all others will start using the address of the sender, so that becomes unicast. So hello packets are not always multicast. That is what I want to say. Hello packets are not always multicast. If it wants to use multicast address, it will use only when the neighbor is unknown. When the neighbor is unknown, it will use multicast address. What is the multicast address? 224.0.0.5. So these hello packets are sent every 10 seconds. Once everything is fine, they exchange the DBD. This is not a class, OSPF class. This is a revision class. So let me quickly tell you. This is init state. In between, you have 2A state, start state. When all the states are successful, then only the exchange state comes. This is start, this is exchange. The exchange DBD, that is type 2 packet. OSPF packet type 2 is exchange. Type what? Hello packet. With a hello packet, it knows who is DR and who is BDR. Once the DR BDR election is done in the extra state, the exchange state type 2 packet is sent. And this type 2 packets is not a complete database. Say it is complete database, but not the detailed database. It is the summary. Summary of LSDB is what called as DBD. Summary of LSDB is what called as DBD. So the DBD is exchanged. And when the receiving router has some query related to some network in the DBD, it will send a request, which is called as loading state. After exchange state, the loading state comes. In the loading state only, the response to the request also sent. And then they send acknowledgement for LSR, LSU, DBD. For all this, every now and then acknowledgement is also sent. After a point of time, there is nothing to learn. They are fully synchronized. That is called full state. Now, coming back to the story, LSR, if someone is sending LSR, the receiving router will send LSAC, instant acknowledgement. And if someone is sending an update, and link state acknowledgement is sent. If someone is sending DBD, link state acknowledgement is sent. So acknowledgement is sent for every packet except hello. All other 3, 2, 3, 4, all 3 will get an acknowledgement. Sender will receive an acknowledgement. So this may be another question. 5 packet types or OSPF packet types. Hello, link state. Hello, database description, which is nothing but link state database in a summarized manner. We can also call this DBD, that is type 2. Don't think this 1, 2, 3, 4 as a sequence number, serial number. No. This is the number allocated. For example, if you capture LSR, the number will be 3. Let me show you. You can see here packet type 1. It's a hello packet. And if you go down, DBD, see, number 2 means DBD. It is reserved like this. And then you see number 3, LSR. Number 4, LSU. And then number 5 is acknowledgement. So these numbers are fixed for the type, packet type. Right. So these are all the fields that you will see in a OSPF packet. Let me quickly walk through this. See version number, type, packet length, router ID, area ID, checksum, authentication type, authentication string, data. This is exactly you see here also in the OSPF packet. You will see the version. You see V2. That's what here you see version. And then type. What type of packet? This is acknowledgement packet, type 5. And then packet length. You see packet length is 44. And then router ID. You see the router ID here. 10111 is the router ID. Next, area ID. It belongs to area 0. You see backbone area ID. And then you see checksum value. Checksum. And then authentication type, authentication string. See, authentication type is null. Authentication data is also none. And this is the payload of OSPF. This is the data of OSPF. You see data. See, I told you no sequence number. You see sequence number. 0x80000036 sequence number. Right. So these are all shared. This we already discussed. Kindly go through this. I'll give you a second. Not second, a minute. Let's go next. The states and all, you know it, but I'll quickly walk you through this. See, initially they are not neighbors. There's a first neighbor. Hello packet goes with a router ID saying, I am so and so. These are my neighbors. See, the hello packet's neighbor list is sent. In the hello packet, neighbor is sent. Let me show you that screenshot. See the hello packet here. This is a hello packet. See, type 1. And you can see neighbor, active neighbor 10.1.1.2. So for router A, there is no neighbor. So it is saying I see no one. And it is using a multicast address. Now B learns A and it starts using a unicast to send the hello packet with the neighbor. Who is neighbor for B? A. So it puts A's address and sends it. When A finds its own address in the neighbor list, it understands that I need to go to two-way state. Initially it was in init state. Init state means the first guy initiates. When the second guy sends the hello packet with first guy's IP address, that forms two-way state. Once two-way state is done with all the neighbors, if it is LAN, there may be more than two routers. If it is WAN, there will be only two routers. If there is LAN, there will be more than two routers. So in the external state, there will be a election process. The priority will be compared. The high priority becomes the designated router. The next highest will become the backup designated router. If all have the same priority, then the one with the higher router ID becomes the DR. The next higher will become the BDR. This decision is made in the exchange state. And then comes this decision is made in the extra state. After 2 ways, extra. After extra, they go to exchange state where they decide who will exchange, who will initiate the exchange. The one with the router ID higher will always initiate, the others will follow. So who will exchange first is decided in exchange state, and they exchange accordingly. What do they exchange? They exchange DBD. What is DBD? It is the summary of LSDB. Once the exchange is done, there will be some queries, some clarification needed, and that is where LSR and LSU comes into picture. The queries are sent and detailed informations are replied. This is called LSR and LSU. This happens in loading state. At last, they are fully synchronized and becomes full state. The sequence number, every time there is a change, the sequence number is incremented by 1. When all this becomes FFFFF, then this 8 will become 7, so that it can restart again from 8001. Not only that, this gets resetted from whatever the state is, it will get resetted every 1 hour. Every 1 hour they reset. So don't think, what if this get exhausted? What if all the bits, every time, change happens, sequence number gets incremented. What if all this number, it's a hexadecimal number, what if it all reaches F? Don't worry, it will reset back to this one and start from the beginning. Even if it don't exhaust, every 1 hour, it will get resetted automatically. All right, not only that, every 30 seconds, whether there is a change or not, periodic updates are sent. Understand this. Many people don't know this. They think that only RIP will send periodic update. No, no, no. Even OSPF sends periodic update every 30 seconds. Sorry, 30 minutes. RIP is 30 seconds. That is worst case. Here, this sends the DBD every 30 minutes to make sure that everyone has got same identical database. All right, if you want to see the sequence number, you can see it in the same command show IPOSPF database. Here it shows that this update was received 8 seconds ago. 8 seconds ago from this advertised router 192.168.1.67. All right, there are some debug commands. So debug IPOSPF packet will show you the packet intent. You see, earlier I showed you in Wireshark. Now I'm showing in the debug, in the CLI. What is this? Version. What is this? Type. Type 1 means what type of packet it is. Hello packet. Length of the packet. Router ID. Area ID. Checksum value. Authentication null. No password, none. Payload it won't show. So you can see this one in Wireshark like this. You see packet length, type, version, same thing. Version, type, packet length, and then router ID, and then area ID. Here this is area 1. Then in that output it was 0. Checksum value D882. Here also you have checksum value D695. Authentication type null, authentication data none. Same thing here, authentication type null, 0. Authentication data none. And this payload won't be shown in debug because you won't have enough memory. All right. So this chapter was again interesting, and a lot of questions in this chapter. Though it is simple, they will say like type of packets, What is DPD? Then what is that extract state? What happens in loading state? What is happening in loading state? LSR and LSU. And will the multicast address be always used to send the hello packet or not? Answer is no. Initially, first time to discover the neighbor, they don't know each other. So discover the neighbor, it will send to a multicast address. Once the neighbor address is known, they will start using unicast. Right. So these are the questions. And another question is how often the sequence number gets resetted. Every 1 hour that you can see here. You see, every 1 hour. It will get resetted, and every 30 minutes updates are sent.